Hello, everyone. Good afternoon. I hope you can all hear us. If you cannot hear us, please leave a message in the chat so we can see where the problem is. But welcome. We will wait a couple more minutes because we see some more people coming in, and then we'll start with today's webinar. So stay tuned. All right, so we think most people are there, so let's get started. Welcome, everyone. On behalf of Siebe Construction, we would like to welcome you all to today's webinar. My name is Maud, and I'm part of the sales team here at Siebe Construction.
My name is Jasper van Noa, Learning and Development Manager at Siebe Construction.
At Siebe, we want to spread knowledge on 3D concrete printing around the world, and that is why these webinars will all be free of charge, and so today as well. The webinar will also be available on demand on our online community platform and on our YouTube channel. So in case you want to rewatch the webinar or you want to forward it to any of your colleagues, feel free to do so. If during the webinar there are any questions about the topics, feel free to ask them in the chat so we can answer them. Our moderator is here with us today and will be answering your questions. But at the end of the webinar, there is also, as usual, room for a Q&A. So you can also wait with the questions and ask them at the end of this webinar. Also, don't forget to note the dates for the coming webinars. In the next webinar, for example, we will host with our partner Betonindustrie Brievengat from Curaçao. And there we will talk about how to integrate 3D concrete printing in your company. And we will also discuss the projects that they have been doing over the past couple of months. So we are very happy that you are here with us today. And therefore, we were wondering...
Yeah, before we start with the webinar, we are wondering, how did you find out about this webinar? So you can fill in the poll below. So we have our interactive webinar. And you have like 1 minute to fill in the poll below. How did you find out this webinar? Okay, LinkedIn. The most I found is via LinkedIn. Also via our newsletter. That's really interesting. Yeah.
All right.
Cool.
Good to see.
A few more minutes. Yeah, so the most are from LinkedIn, some from a newsletter, some from Facebook, so that's really cool. Okay.
As mentioned before, at Siebe we want to spread our knowledge on 3D concrete printing around the world. Therefore, today's learning objective is divided into the following parts on how to calculate the material usage, total cost of a building, traditional construction, and the return on investment. All these elements together will allow you to create a solid business case for your company to see what the numbers of 3D concrete printing of a house would be for your company in your country. The first element we will address is how to calculate the direct costing of a housing design. After that, we will explain how to calculate the overhead costs, and in the end, you will know how to calculate your return on investment on the purchase of the 3D concrete printing equipment. So first, we will start with a brief introduction on why we actually started developing the solutions we offer today. So in 2013, Siebe Construction was founded to automate heavy labor to solve the global housing shortage and the growing lack of workers around the world, as people are becoming more educated. Our CEO Barry Hendricks had been working in the construction industry and leading projects in his family business Hendricks for years. While he struggled with the fact that the construction industry is actually shaped around a highly labor-intensive workforce, and this limits the ability to innovate and increases the risk of high cost of failure. At that point, he began looking into solutions to build faster, cheaper, and more sustainable. And one of the most important benefits of 3D concrete printing is the increase in capacity it allows for construction companies. Because of our fast-setting material, we can print at a high speed of 500 millimeters per second. The hoisting of the elements can be done after 24 hours, and the finishing work can therefore be done immediately after. This results in less overhead costs, less labor costs, and more housing can be done in the same time frame, which will eventually increase in companies' cash flow and profit. On top of that, we also contribute to building more sustainable, as less material is required to achieve the same structural strength as with traditional concrete. Less material, therefore, also means fewer gas emissions. And in addition, 32% less CO2 is emitted during the production of our Siebe mortar compared to traditional Portland cement. Our focus is on construction, and our thoughts are during every step of the process. One very important part of the process is the setup of the cost calculation to predict the quantity, cost, and price of resources required to complete a job within the project scope. Cost estimates are used to bid on new business from prospective clients and to inform your job and budget planning process. In this webinar, we will explain to you how we make the cost calculations within Siebe, and this is therefore based on how we used to doing this in the Netherlands. We want to explain to you the process and how this applies to 3D concrete printing, so you are able to make the calculations that apply locally, so in your local unit of measurement as well, as this differs from country to country. We start with the program of requirements. This is the starting point of designing buildings. A program of requirements provides insight into the structure, size, quality, and cost of the design. Furthermore, an overview of the time schedule can be shared. With the program of requirements, the client specifies the criteria the building should meet and what the wishes and needs are. Then you move to the conceptual design. The conceptual design phase is to establish the size and shape of buildings. The most fundamental choices are determined in this phase, such as the massing and the spatial configuration. After that, you move on to the final design, in which the final decisions are being made and the output from the technical design phase, such as 2D drawings and 3D models, are delivered. With these drawings and models, the subcontractors can then realize the building. In the last design phase, the designers will conduct operational tasks. The final design of the 3D building models is delivered, and the design focuses on planning, preparation, the construction site for printing, and the construction of the building. During the construction phase, the cost calculation of the budget is being monitored and managed, and care is taken into incur a higher cost than initially budgeted. During the initial aftercare, which is after the construction phase, the construction planner can make a post calculation. In this post calculation, all costs are calculated, based on the real cost incurred. Cost of failure, less or too much calculated labor, used materials, and the cost for equipment and subcontractors will be calculated. And based on the post calculation, a comparison can be made between cost calculation and post calculation. This could be the input for the next project, for example, so the cost calculation will be more precise every project that you do. After all, this is learning by doing.
So, how to start with making a cost calculation? The first step we do is calculating the direct building costs. The direct building costs are the cost of material, labor, equipment, and subcontracting. For the material, it's all the material that is used in the project. This could be a total price. So big companies have these prices in the database and got these prices automatically updated when material prices changes. Some of these prices are counted per meter, per square meter, or per cubic meter. To get an indication of this, a calculator first needs to inform the supplier of the current material prices. With a 2D or 3D model, the amount of these materials can be calculated. For the labor, it's all the labor of your workforce. This has to be an estimation which is made by the work planner. In construction companies, the labor for example, plastering or tiling are well known. So the construction planner only has to calculate the total of square meters and will multiply this with the labor number. So for the equipment can be the rental of materials and equipment. So for example, to rent a digger. The subcontracting is the subcontracting other costs and is most of the time a total price that has to be paid for subcontractors. So this is usually a total price. It's not a price per square meters. So all these with these direct building costs, we can calculate the overall costs. Those four elements, so the material, labor, equipment, and subcontracting, result in the total direct building costs. With these total direct building costs, we are going to multiply this with four elements to get the total building costs. And we first multiply the total building costs with the general construction site costs. The general construction site costs are costs for example, so the facilities on the construction for the site workers, building site equipment and management, but also, for example, the rent of toilets for the staff. So after that, we are going to multiply it with 6%, and that are the general construction costs or the general overhead costs. These costs are not directly linked with the project itself. So that are overhead costs for example, the management or the corporation for corporate management, or for example for the business office and calculation, or for marketing, sales, and other general administration. After we calculated the general construction costs and the general overhead costs, we will multiply that number with 3%, which is the risk and profit. Profit is the amount remaining after all costs and risks associated with the project have been settled. Risk includes all unforeseen circumstances, such as non-compensatable wages and prices increased. It also includes loss of interest, the inability to carry out work due to rain, waiting times due to late delivery, or repairs to equipment. After these, we are going to multiply the total number with the car insurance. The car insurance is the construction all-risk insurance, and it insures you against material damages that occurs during the construction or assembly of buildings, roads, bridges, or installations. Think about damage caused by fire, storm, or theft, but also damages caused by construction errors, designing errors, or construction faults. A standard property insurance or building liability insurance does not cover the risk of reconstruction activities. So we have the subcontractors, and we have also all the subcontractors will do the same math for the direct and the indirect building costs. So which means the total number of total costs of the subcontractors are also multiplied with the general construction site costs, general overhead, risk, and also an insurance. What we are seeing is that also this is done by the subcontractors of the subcontractors. So on this page, you can see that the subcontractors of the subcontractor is also doing the same math as the general contractor. And by this, the costs of the subcontracting are getting higher and higher. So this is a thing to have into account when you are contracting your subcontractors. So how to start with making your cost calculation? In the Netherlands, we have the STABU, and STABU is a standardized list of elements which have to be calculated in your calculation. It's a very big document, and it's also very traditional. So, for example, to calculate the cost of concrete printing are not described in this document. So for project management, it could be helpful for you to have an overview of all the elements, and so that's why it's a standardized code. So this is a list that is usually used in the Netherlands. So in other countries, maybe you have also another code, another standardized list. So we will give you an example of how we made the cost calculation of the direct building costs. And we do this by the example of the Robust Villa. So to give you this example, we do the calculation of the project Robust Villa, which is a project we did in the Caribbean. This building was 60 square meters large, and for this project, the hourly wage of labor was €9.63. So as you can imagine, the number of labor and the wages is depending on in which country you're in. So the Robust Villa is one of the in-house designs buildings of our Live label. The buildings in our Live label are developed so that they are easily to build and also are easily built with the 3D concrete printer. To achieve the highest efficiency with our printers, the design of this house is very important. That's why our architects are looking for new designs where they can take factors into account such as spacious, comfortable, sustainable buildings and which are faster to construct. So for this example, you see here the spreadsheet of how we calculated the direct cost, and so we are going to now go to the spreadsheet itself. So as you can see, we have our building size of 60 square meters with the €9 and 63 euros for the wages. At the left side, you see all the elements that we have calculated for the construction. So we start with mapping, foundation, concrete works, further below brickworks, frameworks, etc. So how to make a cost calculation? We first give an indication based on the 2D or 3D model about how much material, for example, we use. So it could be material, it could be hours, it could be equipment. And so this is where here the unit is displayed. So for example, for the foundation strips, we have square meters, but for example, the sand, we have a cubic meter, or for example, for the renting a digger is per day. So for the leveling foundation strips, we estimated that we had work on it for like 7 hours. So the total labor is this number. So this is the number of the total working hours multiplied with the costs. And in the columns here you can see the material and the total material. So the total material is a price which we have calculated by the material factor, and the material factor multiplied with the amount we needed. So because we are experienced in making cost calculations, we know what the material factors are, and also, for example, the hour factors. So we know, for example, if you are working with leveling foundation strips, the factor is 0.15. So it means that if we have a total of, let's say, 50 square meters, we need to work on that for 7 or 8 hours. So this is done for every post in the calculation, and it's depending on, for example, we also will calculate how much material we use in kilograms. So that will depend. Okay, if we need for reinforcement 240 kilograms of reinforced formworks, we know how long to work with that, and that brings us to a total price. So in these three columns, you can see what the total price is for example, traditional construction and 3D-CP construction. And because we know what our factors are, we can use the amount. So if we have a different amount for another project, we can change these amounts quite easily. So yeah, we can also make a new calculation based on the factors that we have described for the material and for the labor and for the hours. So as you can see, yeah, we calculated all the elements of the building for the brickworks, frame, windows, and doors. How to make roofing, plastering works, tiling, cement, painting, etc. So all the elements of the building are described here and are yeah, based on from the amount, how much you need, and it's estimated how long you have to work with it, and also how much material you need.
So with 3D concrete printing, you cut down a lot of the human error on projects. So what we are wondering is what for you are the main factors why construction projects get delayed. So please fill in the poll below. This could be problems with the delivery of materials, the underperforming of subcontractors. What we hear very often is the shortage of skilled labor, but also inadequate planning, the budget conflicts, or maybe environmental issues, or maybe something else. So you can select others and put it in the chat. All right, a lot of different answers, as we can see. All right, thank you very much. So now you know how to calculate the direct building costs of a building, and the next step is to zoom in on how to calculate the costs of a 3D printed wall. And this all starts by calculating the amount of material that is required for the walls. So the first step herein is determining the layer system you will be using for the project. This is something that usually depends on the local requirements for insulation and the structural strength. Because of the technique we use, we can print cavities for structural columns and beams integrated in the walls. And this is because we use a layer width of 40 millimeters, which is enough to construct structural walls. And in this case, you reduce the material and therefore costs, instead of printing, for example, 80 millimeters, which is also something that does not allow you to print smart construction details such as the cavities. And to calculate the material of the number of material that you need, you first need to know how much material you need in cubic meters. So this is done by a formula by multiplying the length of the wall with the wall height. After this, we multiply this with the layer width, and our layer width is, as I mentioned, standard 40 millimeters, so we multiply this number with 0.04. This number is multiplied by the number of layers, so for example, for a 2-layer system, we multiply this with 2, and for a 3-layer system, we multiply this with 3. With this number, we know what the total number of cubic meters of mixed wet mortar we need. The volume of the mixed mortar, water and additive, is, as you know, bigger than the dry mortar. And because of this, we multiply the amount of cubical meters with a factor. And to calculate the factor to a pallet size, we have to divide the number with 2,200. So, for example, in the formula, the length multiplied by the height multiplied by the layer width, and in our case, which is 0.04, the number of layers, so let's say 2, and the factor of the infill, and then multiplied by 202,000 divided by the 1,200 to calculate how many pallets of dry mortar we need. So to put the aforementioned into practice, we will fill in the length of the walls and the height, and this will calculate the square meters of the wall that we have to print. Based on the formula, the amount of pallets that we need to use for this wall is calculated. So this means for our 7 elements for the robust villa, we need a total of 15 pallets for a 2-layer wall system. And in this overview, you can also see how much time we expect to print and what the total costs are of working hours and material. So we expect to print 16 hours. We need 2 operators to operate the system, and with an hourly rate of 9.63 euros. So this brings up to a total cost of labor of 308.60 euros. The total material that is required costs around 475 euros per pallet, which comes to a total of 7,125 euros. These prices are based on the Siebe Mortar ready mix. So this means that they can be lower if you produce the material locally, for example with our Siebe powder pack. In total, this brings up to a labor and material price for the printed walls of 7,433 euros. So now we know we can calculate this number to take into account with the direct building cost. Because many of our partners are located outside Europe, we offer the ability to produce the Siebe Mortar locally. As before mentioned, this we do with our powder pack, which is basically the mixture which makes our material fast setting within 3 to 5 minutes, and this will be 30% of the total mixture, which can then be mixed with your local sands to the printable material. And the benefits of this is that it lowers the material costs, the CO2 emissions, and it cuts down on the transportation costs. But of course, you're also free to use what material you will want to use to print with. So then we move on to the direct and overhead costs for 3D concrete printing. Besides material costs and labor costs, which are then the direct costs, there are also overhead costs for 3DCP. These are, in this case, the spare parts for the mixing pump system that will be needed to realize the building, such as a rheostator, a concrete hose, a mixing iron. And for this, we always calculate a factor. For example, we know that a mixing iron can be used for approximately 40 pallets of material. So this is something that we then take into account according to the project that you will be building.
So what are the differences in making a cost calculation for 3D concrete printing and traditional construction? So we use our cost indication for robust villa to make to compare the costs of it. So so this document you understand this document now. So in here you can see the cost of the traditional construction and the 3CP. So as said before, for example here the mapping and the foundation, there are no difference between traditional construction and 3CP. So the costs in these two columns are the same. So if you go further below, we see also the concrete works, so the foundation, this part here, foundation, and also the ground floor, so the concrete slab. Those costs are all the same. So as you can see here, costs are the same in both columns. Further below, we see here our orange dot. So the orange cells means that we have a difference between traditional and 3CP. And for this, we have a difference in the concrete ring. So the concrete ring beam, we have costs for making a formwork. So the making traditional formwork is made of wood, but for concrete printing, we can print the formwork within our wall, and that's why we don't have any costs for making a wooden formwork. So as you can see here at the right, you see for the robust villa on a traditional way, you see 1,400 euros for traditional construction, but for 3CP it is you don't have those costs, and the same for this part here. So there you have a small reduction of costs. So if you are going further below, see the concrete roof. The concrete roof is built on a traditional way without 3CP, so no difference in there. And then we have the brick work part. As you know, the brickwork is replaced by 3DCP. So for traditional housing, you can see the cost of the brickwork in this column. But for 3DCP, you can see the cost in here. In the orange, in the yellow cells, you can see the costs, what could be possibly replaced with 3DCP. So it is possible to print the formwork of the foundation instead of 3DCP instead of brickwork. But for the Robust Villa, we build it on a traditional way. And so here for the brickwork, you can see here in these cells, these are the costs for the traditional construction of the brickwork. But because we will do it with 3DCP, we have those costs. Those costs are based on the cost indication as described by Maud earlier in the webinar. So further below, we have also for the brickwork of the roof curb, we have here a reduction of costs. So as you can see here, for making the walls, we have a difference between traditional and 3DCP. So the making the frames for the windows and doors, this part is all the same because it won't differ between those production methodologies. The same for the roofing. As you can see here, the plasterwork, you have here differences because traditional brickwork will be just plastering, but for 3DCP, no plastering is needed. So you don't have internal plastering and you don't have external plastering. So that's a reduction of cost because the surface of 3DCP is really strong. It's sustainable, and we love the outsides and the structure of the walls. So we don't have to plaster it. Furthermore, for example, the tiling, which you can see here, cementcrete, and also for the painting, it's not different. So these costs will be the same, and also for inside kitchen, etc. Those costs will stay the same. A slightly difference here compared to traditional, compared with 3DCP, is this row. So in this row you can see chopping and breaking work. When printing our 3D walls, we can cut the wet material out with a knife. So we don't have to do the chopping and breaking after, and we can do it during the printing itself. So that's a small reduction of cost. So we have here, you can see the difference between the two methodologies. So we have a difference of about 1,000 euros. So it brings here to a total direct cost saving of 1,000 to 1,000 euros, and there's about 2% of cost savings. And those are the direct cost savings. So the conclusion of the calculation of the direct building costs is that the amount of material, labor, and equipment are the same. So you have a slightly less cost, about 2 or 3%, but it's all depending on the material price of our civil mortar. So this is based on the ready mix, but if you can make your own material with the power pack, you can reduce your cost because you can buy your material locally, and also the labor total is also depending. So the total of labor is depending on how much hourly labor rate is, and so that's why it can vary from country to country. So now we have calculated the total direct building costs, and as you know, to calculate the total building costs, we have to multiply the direct building costs with the indirect building costs. So in this you can see how an example of how that's done. So if you have, for example, a house that cost direct building cost 100,000 euros, that's multiplied with 15% overhead cost, 6% general overhead cost, 2% risk and profit and insurance. And it brings to a total here of about 126,000 euros. So that's what we're also going to do for our robust villa. But the real importance of concrete printing and the effectiveness of the printing itself, that's a big advantage between the two methodologies. So what we can do with concrete printing is we can make a building in 5 weeks instead of 25 weeks. So for the robust villa, you could build it in 25 weeks. Now we can reduce the time with 20 weeks. So that is a total time capacity of increase of 500%. And as you can see here in the loops, you can, in every week you can print, and that's how you can have the efficiency of the printer itself. So what's the effect on the overhead costs if you can can build a house in 5 weeks instead of 25 weeks? In this overview, you can see the cost that you have for the overhead. So, for example, you have to rent a toilet, you have to rent fences, alarm door, and because now you can build it in 5 weeks, you only have these costs for 5 weeks and not for 25 weeks. And what effect has this on our calculation? So for our robust villa, we had a direct building cost of about 41,000 euros. And if we calculate this number, you can see for one project you have about 6,000 euros of over construction general construction site costs, and you can see here the profit is about 1,500 euros. So it brings to a total price of 52,000 euros. But instead of building one project in 25 weeks, we can build 5 projects in 25 weeks. So at the right, you can see the overhead cost of 15% of 25 weeks. So if we divide, but we can build 5 times faster. So that means that we have 5 times less overhead cost. So instead of having 15% overhead cost, we can calculate with 3% overhead cost. So what does this mean for our construction site cost for our robust villa? The total of overhead cost was 6,000 euros, but if for 5 weeks we have the total overhead cost of about 1,000 euros. So to compare these numbers with traditional, we have a cost saving of and our material. So that are the direct building costs of 1,000 euros, but we have also a reduction of cost and overhead cost of about 5,000 euros. So that means that the total of overhead costs and the total of direct building cost savings is 6,000 euros for the project. So that's a reduction of a total of about 15%.
This is actually something that we see happening a lot, that there are misconceptions about the relevance of the time in 3D concrete printing. Because what is very important is that in order to create affordable housing and to have a response to the housing shortage that we have at the moment, we can now print, instead of one project in 25 weeks, this can be reduced to 5 projects over this amount of time. So this is very important also in terms of profit and the cash flow that we see happening. This is something that's very important to consider what 3D printing can do, therefore.
So that's only specified on the costs, so the overhead cost and the direct costs. But we have also our risk and profit, what we have. And normally we have 3% per project. But we can now build 5 projects in the same time. So in this table you can see, okay, in 5 weeks, on a traditional way, you have a profit of 500 euros. And so total in 25 weeks of 500 euros. But with concrete printing, we can build 5 projects, which have a total of 7,500 euros of extra profit, which you can make per 25 weeks. So it has 2 sides. It's a reduce of direct building costs, reduce of overhead costs, and a total of more profit per project. Poll, and the poll is: were you aware that the advantage of 3DCP is not a significant reduction in direct construction cost, but rather a faster construction process? You can fill in your answer below, and we are really wondering what your thoughts are. Okay, cool. So a lot of people were aware of this. Somebody was not totally aware of it, and some are partly aware of it. Okay, that's interesting. Okay, cool. So most of you, the poll's still going. Yes, it's mixed. So some of you did already know that the cost of the biggest advantage of concrete printing is that you have a faster construction process, and some of you did, know that, and some of you not. All of you did exactly know that. So that's really cool.
So as Jesse mentioned, one of the main important parts of creating a solid business case for 3D concrete printing is to get the most out of the machine and achieve the highest overall equipment effectiveness. And we do this by maintaining an efficient printing strategy and construction process, as explained in the construction loops we mentioned earlier. So how to achieve a fast return of investment? In 3D concrete printing, time is probably the most valuable factor, as this means a faster return of investment. And, therefore also, a more positive cash flow within your company, as projects can be delivered sooner. One of the factors to achieve a high overall equipment effectiveness is that you will need a low setup time, which increases the availability of the printer itself. Because of this, for example, our mobile printer is very flexible and the setup time is, compared to the printing time, very high. So therefore the overall equipment effectiveness is also very high. At SIBA, we want our partners to achieve the highest possible overall equipment effectiveness, and this to make sure that they have a fast return of investment. Because a 3D concrete printer which is not printing means less revenue. So then how do you calculate the return of investment? The importance herein is to have an effective printing strategy. As Jesse mentioned before, this has also to do with the effectiveness of the machine and how you use it. So one of the main benefits of our SIBA crawler is that in the first week, the site preparations and the floor slab can be done, and in the second week, the printing of the wall elements can be done. After this, the printer is finished, so the printer can move to its next project, and then the finishing of the house can then be done in week 3, 4, and then 5. So in this way, you have a continuous loop of using the printer, so the printer will print 1 week the first project, then go to the second project, third, etc., etc. And this is very important also for your return of investment, because this means that you will deliver more projects at the same time. So how do you then calculate your return of investment? Basically, this is the steps that we've been mentioning during this webinar. So the first step that you will have to do is to make your business case. Know which projects that you want to be printing. After that, you will move on to the next steps, which are, as we mentioned, calculate the amount of material and costs, calculate the total labor costs based on the local hourly rate, which differs from country to country, calculate the cost of your equipment, and of course the cost of your subcontractors will have to be taken into account as well. After that, you can move to the second step, which will be to calculate the 3D concrete printing material. So calculate the labor that's required to print the wall elements and calculate the prices of the material itself. After that, you move on to the cost savings. So when knowing all the variables, you will also know how much costings you can save by 3D concrete printing. And then you will be able to calculate, based on the reduced construction time, also calculate the overhead costs that you will be having. And then as a last step, you will then eventually be able to calculate the extra profit that you can make by means of 3D concrete printing. So Basically, these steps would be how to calculate the return of investment is, of course, the initial purchase of the printer. We have printers available from 150,000 euros, and which printer is most suitable for your project will then depend on the printing strategy that you will be using and the type of projects that you will be using. Of course, we can advise you in this case which printer is most suitable for your project. Then you have the direct construction cost savings, which are, as Jesse mentioned, between 2 to 5%. But what is most important is that the general construction site costs that you can reduce can be from 15% to 3%. After that, this results in eventually more profit on a project. And so in this case, 500% more profit over 25 weeks because you can keep the pace of producing the projects up faster. So to conclude, the return of investment differs from project to project, as this depends on the design that will be printed, for example, but also from country to country, what the local costs are for example, labor and materials. This will be different in different countries. But based on the business case, you are able to scale up on this one project to several projects. And this makes it possible for you to calculate eventually the return of investment. But don't worry, if you need any help with your project and with your business case, we're here to help you. Just send an email to sales@siebe.eu to see what 3D printing can do for your company and how it can make you a solid business case. Because you're attending this webinar, we can imagine or assume that you are looking for 3D concrete printing in your company. Maybe you're already 3D printing. So we are wondering if you are already creating cost calculations or business cases for implementing 3D concrete printing in your company. So please feel free to fill in the poll down below again. All right, very well. A lot of different answers we can see. Some are setting up their business cases, some are already doing projects. Very good to see. In case anyone needs help with creating a business case, please feel free to send an email to sales@siebe.eu, and we can see how we can help you create your solid business case for 3D concrete printing.
Now we are almost on the end of the webinar. So the Q&A is following. So if you have any questions, please feel free to ask them in the chat, and we or our moderator can answer them. I see a question of Fatima. What is your exact question? What do you mean with a precise equation? Okay. If you have like any questions about whatever concrete printing calculations, always feel free to ask them by sending an email to sales@siebe.eu, or just sending something in the chat. Right now we don't see any questions coming anymore, so we will move on to the next part. For those of you who already have seen our webinar, we have also our Siebe Academy. In our Siebe Academy, we have online courses about concrete printing, for example, about what is the history of concrete printing, about the basics, also about how to operate our systems, and also some in-depth courses about designing 3D concrete printed houses. So if you are interested in educational courses, register in our CIBA library and check also our CIBA Academy. We have also free courses available. So if you are interested or you know somebody who is interested, let them subscribe and check our online courses.
Yes, so then we want to thank you very much for attending today's webinar. We were very happy that we could see you all here joining us today. We will share some files with you if that's required. Just send an email to sales@ciba.eu and we can forward you so you can look at it all again at your own time. So do not forget to subscribe to our next webinar, which is, as I mentioned, with our partner Beton Industrie Brievengat. And there we will handle the discussion about how to adopt 3D CP in your company, and we will discuss their recently done projects. So if you're interested, feel free to subscribe. It's on the 27th of September, same time as usual. So thank you very much again for attending, and we hope to see you next time.
Yeah, and if you want to subscribe for our next webinar, you can do this in the click here in the call to action below. So click here and you are already subscribed for the next webinar. Thank you very much, and hopefully we will see you in the next webinar.
Thank you. Bye-bye.